Oh, another early video. We're just going to get right straight into this. So topics for this week, just basically revision and like this random thing here. I don't even know what they're going to do really because the week hasn't started, but I don't even. It's not going to be very hard, I don't think. And then the revision list for tracking test 4 is just not it. But we're just going to have to deal with it. Just remember my tips for revision. Just remember the standard proofs, so infinite primes, contradiction proofs, like square root of 2 is irrational and stuff like that. Do a bit of vectors revision. Yeah, not the core pure stuff, just the stuff we've been doing in like the ages ago when we did vectors. I mean, you can keep the dot product in mind because it is quite useful, but anyway. And trig is there, that's not bad, and then yeah, and then the stats stuff is pretty fine. All right, let's get into the assignment. Let's do it. Yeah. So let's go back to question 1. All right, so we have some differentiation here. They're actually introducing some of the new stuff into the assignments for once. So I'm just going to go through what you have to use for each. So this is chain rule, this is more chain rule, this is chain rule, this is chain rule, chain rule. Yeah, chain rule. This is chain rule. This is product rule and chain rule. This is product rule. This is product and chain rule. This is product. You can use product or chain, product or quotient rule. I use product. This one I use quotient, and this one is also quotient. So yeah, that's pretty not too bad. So I think we've seen this question before. Well, no, we definitely have seen this question before. You substitute the values in, get your equation, substitute negative p in, get your values, solve, blah blah blah, get those answers. And for part D, you have your value of q, so you know what to use, since you know that x minus 4 is a factor, x minus 2 is a factor, no, x plus 2 is a factor, sorry. So you just do what's minus 4 plus 2, what do you get? What do you make to get minus 40? Well, plus 5. Next, writing single logarithms, I think I just like did these in one. So this one, you just 40 divided by 5, log base 2 of 8. Then this one is just log base 6 of 36, which is 2. This one, you move the 2 to the front, move the 4 to the front, multiply, then you cancel. This one, you just divide, multiply, whatever. And then the last one, you set this to 4 because you bring the 2 over, combine these ones, divide the other ones, and then you get your answer. Alright, next, this was not very fun from them, from the BHASVIC assignment, big BHASVIC assignment, but it's just some divisions. So we're going to get the division, there's some remainders. For this, remember to use ln when it's over a function of just x and not x squared or x cubed, and it's just kind of the same thing. So you get a polynomial, then you get a ln at the end for all of them. So you just do division, polynomial ln, division, polynomial. This one you have to do partial fractions, actually. This is a pretty not very good polynomial, but this one you have to do partial fractions. Remember the absolute values in the plus c, or the modulus in the plus c, when you're doing integration. Next, this was just completing the square, part A. Part B is a minimum, so you use just the stationary point, which you get from the completing the square. Then you substitute, literally substitution, explain why t is greater than 0, where you just say the model decreases when t is less than 0, which doesn't make any sense. So next question, explain why this is not a suitable selling price. Well, there would be negative profit if you substitute it. Given the company made this annual profit, remember this is profit in thousands of pounds, so it's £80, and you substitute it in. I just did a bit of a long. You substitute it into p and then solve for x, but I kind of just like did a bit of simplification. Next, maximizing its annual profit. That's just completing the square again. That's just the you use a completed square form to find that. Next question, we have this here. There might be a different way to do this because you're not supposed to know that cos negative. We haven't done odd and even functions yet, so I don't think you're supposed to know this. But so you have half AB sine c here, so half times 5 times 10 times sine theta equals 15. You get sine theta equals 3/5, and then you can do trig ratios on this. But because cos theta is even, so like it repeats on the positive side and the negative side of the x-axis, it will be for minus 4/5 as well, because there's two possible values of cos theta. And you know that, yeah, cos theta is 4/5, that's it. And negative 4/5. Yeah, I think that's how it works, yeah, sorry. Then BC is the longest side of the triangle, where you just find all the sides. I don't know, actually, no, why does it even, I don't even think it needs to say this. You can still just use cosine rule on it. So, yeah. Next question we have... Did I just completely... I just completely skipped this question. That's great. Well, this question, this was in our... when we did optimization, like 10 weeks ago, this was the example, and it's incredibly easy because it's not even... You don't have to optimize, you just differentiate, set to 0, solve, and then differentiate again, substitute the value, and that's how you prove that it's a minimum. And then the limitation could just be anything, really. Sorry, I don't know how I just skipped the question. Question 9, find the first three terms. This is just binomial expansion. Just remember, anything choose 0 is 0. Oh, no, it's 1, sorry. And anything, like any number choose 1 is that number. So you don't have to write like 9 choose 0, 9 choose 1. You just remember that it's 1 and 9. And then when you go past choose 2, then you can like write that down. And also remember that the minus x squared is plus and stuff like that. Then the first two terms of that at 128 and 36, well, you know, the only term that is just a number is the one where you multiply 2 and a. So 2 to the 9 times a is 128. So you get a as a quarter. And the next one, you can either get the a times minus x over 16 or 2 times bx. They're the two terms that give you the singular x. And you just get that, and then you solve, because you substitute the a value in. Next question, we have some, just some... What have I done? Oh, yeah, sorry. We have some trick stuff, yeah. So, this is right. I did this when I looked at the question as well. There's this, like, first part that I just didn't read. So, you sine theta, well, I've just divided by tan theta. No, sorry, I've multiplied by cos theta. So, this tan turns into cos, and then everything else just turns into whatever it is times cos. Then you turn the sine squared into cos squared, rearrange, and that's your answer. Next, solving it. Solving this 3x version, where you just turn it into the quadratic that you made, and solve. Remember to increase the range by 3 times, and then it will give you your answer. Next, we've got a circle. I think we've seen this question before. Yeah, I think we have seen this question before. But so first one, obviously, you just complete the square, find the radius, whatever. You can see that the x minus 3 squared, you can do this really fast, because x minus 3 squared is x squared minus 6x plus 9. So this completely cancels out this constant here. And then now you just have x minus 3 squared plus y squared plus 10y equals 0. And you can basically just do it in your head. And the line with this line, the thing that helps you here is that it doesn't have a plus c, which means you can just substitute it into this equation, and it will give you something you can use a discriminant on, because it tells you that it cuts at 2 points. The constants will cancel. You get k equals 0, k equals a over 15. You do the quadratic inequality, and those are your values. Well, that's your range of values. Next, we have this integration question. So we find the normal first. You find the equation of the normal. Next, I drew it out. So you have the area here is 36, because the distance, this point is 4, 6, because it tells you in the question. So you know this distance is 12, this distance is 6. So you do 12 times 6 over 2, get 36. Then you integrate between 2 and 4, and you add that on to your area, and that gives you the answer. Right, so now we have some vectors. This is some like those hard GCSE questions where you have to find the ratios of the lines. So I don't even know if I did this right, but I did get the right answer, because it didn't really look like I did it right. But anyway, so we know that... Oh yeah, explaining vector questions like this is really annoying. So you find OE, obviously, because it's just a plus b plus c. Then OM is 3/4 of that. You know that FE equals just A, and that means FP, because you're finding FP to PE. So you know that FP is lambda A. And then you can find FP by going from here to here, or no, they went, yeah, back like this, down here, like that. Yeah. So going from F to P, no, sorry, going from F to P, you're down, across, up like this, and then minus this here. Or no, plus, sorry. So it's FB plus BO plus OM plus MP. That's F to P, which is this here, this expression here. And, well, that's another expression for FP, then you can set them equal to each other. The minus B minus C cancels, and you get this equation, which you can just do this. I didn't, because there was only one scalar, which made me think that I'm not doing anything right, but I did get the right answer because it's 2 to 1. Next question, we have some integrations and other stuff. So this is they were trying to make you think with this question. So given that k equals 0, find the gradient, blah blah blah. So I just use chain rule for this. For the you differentiate, substitute, get your answer. Then part B, find the value of that when x is 8. Well, this is just partial fractions because you can factorize this. Then blah blah blah, you get your answers. Next, why can't you calculate the value when k equals 1? Where you just say that y, you say that is an asymptote. And I think that's all you really have to say, because you'd be integrating like over an asymptote. But let's say if it was just 1 over x minus 1, you technically would be able to integrate from 2 to 0, because it would look like this right part of the graph would be flipped downwards, and you would be able to, it wouldn't diverge. Diverging just means it would just be infinity, because the if it was just 1 over x minus 1, then the two infinite areas would cancel out, and you would just get whatever like area you wouldn't get there. But because it's x squared, both of them are up here, which means it would just be an infinite area and then another infinite area, so it will just diverge and it will be infinity, which means you can't calculate it. Because whenever you have an infinite value, it's not actually infinity. It just diverges, which means that it's just going to keep going up, which means it's impossible to find the area. Next question. This was horrible. I don't know why they did this to us. So I used L'Hopital for this, but you can use a small angular, because they didn't say that you could assume that cos h minus 1 over h was 0 and that sin h over h is 1. Usually, like 99% of the time in the exam questions, they'll tell you that you can assume these two results. But I proved it using L'Hopital. And then after I proved it here, I just assumed it for the next question. So this one was like a full proof with 2f dash of x's, all the limits, all like no missing steps. And then I kind of just half did these ones like this. And then the tan one was a bit weird, so I expanded tan using the compound angle, and then I turned it into times 1 over h. And then this factorizes, you can take tan h out of the numerator, and you can prove with L'Hopital that cancels into 1, so that just completely cancels. You get 1 plus tan squared x over 1 minus tan x tan h. And then you can also prove that tan x tan h would approach 0 when h approaches 0, which means it's just over 1, which means it will cancel and it will just become 1 plus tan squared, which is x squared. Alright, next we have some stat stuff. So this is just putting it into a calculator. This is also just putting it into a calculator because you just put it into the answer box instead of into the other box. Same with all the stuff, it's just the same thing. Why was this one? Why was EI undefined? Not too sure. I don't think it works when you put it in your calculator or something like that. Yeah, I don't know. Next, so 2 conditions for binomial distribution, independent events and fixed number of trials. There's a few other ones as well. Then it's just some binomial distribution stuff. So this one is 1 rock, so it's x equals 1. At least 1 rock is greater than or equal to 1. Then now they want x distributed binomially of n 0.1 when that is not when that's greater than 1, greater than or equal to 1, it equals 0.95. So you do 1 minus, you can't do p of x is greater than or equal to 1 like without your calculator, because you can't do this in your calculator since there's an unknown. So you do 1 minus p x equals 0, and then you just use your definition of the binomial distribution, which is in the formula book, so you don't have to worry about that. Then you solve with logs. And I took the ceiling of it just because this just means you round up to the highest number. No, you round up to the next number because it's a number of years. Oh no, sorry, it's a number of rocks, not so you can't have a decimal. This was just some tree diagrams. So this one is just this. It's just again tree diagram. You can draw the tree diagram if you want, but you don't have to. You can kind of do it like this. This one is the same thing except there's 3 different ways. There's 3 different combinations of this, so you can just multiply it by 3. Next question, we have some small angle approximation. So it's only really hard when they add cos to it because you have to do the 1 minus theta squared thing. Remember, if the number is before the thing, so if it was 3 cos x, it would be 3 brackets 1 minus theta squared over 2. But because the 3's here, you just replace the theta squared with 3 theta all squared. So it will become 9 theta squared, like this, and the 1s will cancel, you get your answer. Same with this one, you substitute, get the answer, and then this one's really easy because you just turn sine 2x into 2x, and that is your answer. Next question, this, I don't even know what this was supposed to really do. You just have to turn these both into their Pythagorean counterparts. And then proving this is just, you just expand it. It took me a while to figure, because like figuring out which one, you have to do each of these separately. So tan cot turns into 1, cot sec turns into something like, I think, yeah, sec squared cosec squared. That's just something I just wrote like that, and you have to do each one individually and very carefully. And then once you're done with it, it will cancel out because you can combine these fractions and it will turn. That's an interesting identity that sec squared x plus cosec squared x equals just sec squared cosec squared x. So you can interchange the addition and the multiplication. And anyway, next question, we have the speed time graph, finding the area as well. This was really not that interesting. Next we have some pulleys. So you remember, think of yourself as the particle or whatever that's being pulled. So the tension's going this way, and then the tension on the pulley. If you think about, if you're the pulley, you're getting pulled down, or you feel a tension pulling. Yeah, sorry, you feel a tension on you pulling down. And because this one's heavier, it's going to be accelerating downwards. This one's lighter, so it's going to be accelerating upwards. You see, so when you're resolving, R3 is just the resolving the one that's 3 grams, and then this a mass of 3, and then R2 is resolving the one that's 2, with F equals ma, and then you can solve simultaneously, find the tension. Oh, I really didn't know what was going on in this question, to be honest. Like, Lexington mechanics really isn't that interesting. So this one's not that bad. You put them into the time formulas, and then sort of set them equal to each other and do that. That's not that bad. You find the equations of the equations of the velocity for both of them. We're using r equals r0 plus vt, and then solve simultaneously. Part B, find an expression for a, b. You just do that. Like, it's not really not that interesting. Next, distance between A and B at 2. So this is so it's 2. You said it equals 2 because it's t 2 hours after. And then this one, because it's due north, it means that the I component is 0. Therefore you solve, and then you add. So 8/3 is just 8/3 hours past past noon. That's what it means, because it says somewhere. I don't remember where it says, but yeah, time 2 hours after noon. Right. Yeah, this section's kind of boring. I can't lie. Explain why t is greater than 0, so you can't have negative time. state the starting temperature of the cup of tea. They love doing this. You set time to 0, and that gives you your answer, 55 plus 20, because e to the whatever it is when 0 just turns into 1. Then find where it's 50. You just set it equal to 50. That's it. I did some quick rearranging in my head because I can't bother to write it all out. You use learn and then solve and round up because it says the nearest minute. Sketching the graph, you just show that it has an asymptote at x equals 20. Like that. You can use a graphing calculator, so don't really worry, but you should know that because it's e to the x, you just flip it sideways like that. Because the other graph goes up there, so this would just be like that. Question 10, we have this, find the frequency density, which is just frequency over class width from GCSE. The state the coordinates of the first points were obviously 0, 0, and then the next point would just be this first point of data here. And then I have no idea what box and whisk apply is. You can just look at the answers for that one. And then this question, so you find out how much it is lost per play. So you figure out that, so you get £50 if you land on an 8, so that's 0.05 times 50, because the probability of an 8 is 0.05. Add that onto 0.01, probability of a 7 times £20, which is what you win when you get a 7, and that's how you get the amount you're going to win on average per turn. Therefore, it's a 30p loss per play. You multiply that by 150, you get your answer. Alright, these are actually interesting integrals. Well, not really, actually. These are all really easy. So when you have sine squared or cos squared or cosine or cos to any power, you just turn it into double angle. We haven't even learnt parts, but after we learn parts, if you're watching this in the future, it's easier, because I don't even think you can. You could technically turn it into sine cos with a negative if you did parts, but it would just be longer than turning it like this. And then for tan, you just turn it into 1 plus x squared, and it's even easier. Right, this question, I thought this was going to be similar to that question where you proved that the divisibility by 11 method works in a previous assignment, but it actually isn't that bad, because you just say that, the A here is just going to be 100,000 times A, because that's where it is in place value. You add them all together, and then you can factorize 13 out of it, which means that it works, because that's just proved it, because 13 is a factor. Right, we're getting close to the end. This is the last real question. Just solving. You should always, so they in the answer for some reason they want this all in terms of luns. So when you're taking logs of both sides, if you're not doing this method where you're if you're taking log to a certain base to cancel out, I use log base 3 to cancel out the 3 here. If you're using the take log of both sides method, you just always use lun, just because it's the base log. You don't use log base 10, just use you use lun, because that is the basic log. That's the most common log. So, but here, I got this answer, checked the answers, realized that you have to have it in luns. So I used the change of base law, which you see here. So you can turn log base, log base x of y, you can turn into log base anything of y over log base anything of x. So you can turn this into just ln 2 over ln 3, and then you multiply both sides of the fraction by ln 3, and you get this. Next, similar thing, so I still use this method, but I just turn them into luns at the end and then multiply by ln 4 like I did last time. And next we have the best question, the large data set question. When was this collected? Well, it's obviously May of 1987, since that's one of the times when it was collected, of the 2 times. Next, find the modal value for every column. This is absolutely painful to do. And for trace, I don't know why I didn't write it here, but 0 means there's 0 rainfall. Trace means that there was less than 0.05 millimeters of rainfall. Yeah, and that's it. Thank you very much for watching. I will see you after Christmas. Well, no, I think I'm gonna make another video. I'm gonna make another Maths Roulette video before then. But yeah, I'll see you.